This is part 4 of the combined power, heating, and cooling feasibility analysis with the RETScreen Expert software. In this video, we will show an example of a small-scale biomass district heating system analysis. The power, heating, cooling feasibility analysis with the RETScreen software does not necessarily only look at cogeneration. Any combination of the three components is possible. Heating only is one of them. In this example, we are going to look at a district heating system using biomass fuel. In order to start a heating-only feasibility analysis with RETScreen, the user could click on Feasibility Analysis in the home page. Then, a facility sheet, Power, Heating, Cooling could be selected as a facility type and Heating for type. In the energy sheet, the components shown in the ribbon and left menu will be limited to heating only and heating equipment. If the user wants to create a district heating system, multiple buildings has to be selected into the heating load section. When multiple buildings is selected, the district heating icon will appear in the ribbon and in the left menu. The same steps will need to be followed if the user would like to include district cooling. The user could add the cooling system by clicking on the cooling icon in System Selection or in the Facility sheet. And multiple buildings in the cooling load section could be selected. We will now use the Virtual Energy Analyzer to select a built-in example for a typical biomass district heating system for a small community. I will access to the VEA from the home page. For facility type, I will select Power, Heating, Cooling. For type, I will select Heating. In description, I will have Biomass System District Heating. This is the only choice for now, but other choices could be added to the software in the future. For the facility location, I will type Thunder Bay, Ontario. This is near the boreal forest. Biomass fuel should be available. By clicking on Calculate, the software will populate the different worksheets with a typical district heating system adjusted for the climate data of the selected location, which is in this case Thunder Bay. The VEA will propose a built-in example that could be modified as needed to fit my project. In the location sheet, the user could visualize the climate data for the region selected, Thunder Bay, Ontario. The data of interest for a heating-only system are heating design temperature, air temperature, and heating degree days. The facility sheet contains some general information about the project. We are looking at a heating analysis. The VEA has automatically pasted biomass district heating in the description field, and my role is now to complete with some more information such as the facility name and the address. A picture of a district heating system during construction have been also pasted by the VEA. It is possible to replace that picture with your own by clicking on the Select Image option on the top ribbon. The best approach in the energy model sheet is to follow the steps in the ribbon or to go through the left menu from top to bottom. In step 1, System Selection, the user could verify if the good project type has been selected. In this case, only heating is selected. This is quite simple. In the electricity and fuels section, the fuels for both the base case and the proposed case systems are defined. Base case being the heating system used in the small community before the implementation of the district heating system, and proposed case being the proposed district heating system. In the small community, natural gas and diesel are presently being used for heating purposes. The proposed case system will be fueled using biomass. Wood waste have been selected in the drop-down list. The heating value of each fuel could be consulted by clicking on the arrow. If the user would like to define its own fuel, There is also a user-defined fuel option located in the options section of the ribbon. The VEA proposed costs for the different fuels selected. The user could find the actual costs for the area of interest and modify as needed. For the base case, electricity is also being used to heat some of the buildings of the community. A default cost is also entered for electricity. In step 2, the software will first calculate the total heating load for the base case heating system. In the top section, multiple buildings, space heating only is selected. There is no process heating considered for this example. At this stage, the user should already have a district heating system design in mind. In order to teach the user how to design the district energy system, a technical note is available into the online manual by clicking on an hyperlink. Once the user has understood the methodology, it would be useful to draw the schematic of the proposed district heating system and attach it to the worksheet using the district heating network icon. A drawing has been inserted for this example. The proposed system includes a central heating plant, 2 community centers, a cluster of 5 houses, and a second cluster of 15 houses. Each building or building cluster will then be entered into the form. For each of them, a description, the heated floor area, and the number of buildings will be entered. The fuel type and the seasonal efficiency of the existing heating system will also be entered. The VEA has proposed a heating load in watt per square meter for each type of facility. To evaluate this value, the VEA used the building heating load chart available in the online manual. The design temperature was read from the climate database in the location sheet, and the assumed building insulation was medium for the first cluster of building and poor for the second cluster. Since this curve is known to be useful for residential more than for other applications, the curve was modified for the community centers. By using the information from that form and the climate database, the model is estimating the peak load in kilowatt and the heating energy in megawatt hours. Based on the calculation above, the model is also calculating the fuel consumption for each facility. Because this value may be known by the user from utility bills, an iterative method could be used to adjust the heating load of the building until a reasonable match with the utility bills is obtained. In the bottom part of this section, the proposed case heating load is calculated. The only difference between the base case and the proposed case heating load is that for the proposed case, the user is invited to introduce some energy efficiency measures in order to reduce the heating load. This is frequently a very cost-effective and good practice to consider reducing the load of the facilities before the installation of a costly system such as the district heating system. A 15% heating load reduction has been proposed for each building or building clusters. In the district heating section, the user will prepare a preliminary design and cost estimate for the proposed case district heating network. The supply temperature and return temperature will be entered. The differential temperature will be calculated. Then, using the district design layout, the main heating distribution line will be designed. In the main distribution line section, the user will indicate if oversizing is considered. Pipe oversizing is used if it is expected that the system load will increase in the future. In this case, 20% is entered. In the table, the length of each main line section is entered along with the building and building clusters supplied by each section. The software will calculate the load and the pipe size associated with each section, taking into account the oversizing. The same methodology is used in the secondary heating distribution line section. Of course, the district network layout provided by the user is again essential. In the district heating network cost section, the total pipe length is being calculated. Then, the user will be asked to select the methodology to evaluate the cost of the pipes and the cost of the energy transfer station located in each building. A formula costing method is available, which is equivalent to a cost database. The user could also enter each cost individually as user-defined cost by selecting the detailed method. In this case, the formula method is chosen. To estimate the cost, the formula method will need two information: the energy transfer station connection type, direct or indirect, and the construction environment, urban or rural. Using the cost database option, the user could customize the results of the formula method. For instance, I could apply a factor of 1.2 to increase the cost of the energy transfer station by 20%. All the costs will be summarized at the bottom of the section, and the total cost will be calculated. In the load characteristics section, the heating load will be given on a monthly basis for the base case and the proposed case. A system load characteristic graph is also included. Now that the heating load is well defined, it is time to select the heating equipment in step 3. The user will first select the type of system from a list. In this case, a biomass system is being proposed. The fuel type is selected and the fuel rate is shadowed. Multiple fuels is also an option. In our example, we will use a single fuel, wood waste. The VEA selected automatically the capacity that will allow the system to provide all the heating energy required by copying the proposed peak heating load. The seasonal efficiency has been set to 75%. The heating delivered by the heating system is calculated. The user will also indicate if the boiler generates hot water or steam. If steam is selected, more information will be required. The cost database will be used to calculate the initial cost of the boiler. The VEA has proposed an O&M cost of a bit more than $14 per megawatt hour. No intermediate load is required since the system was designed to meet the entire load. In the system characteristics section, the base load heating system is summarized. A backup system of 600 kW is proposed, and a cost has been also allocated for that system using the cost database. The system summary section is showing some basic information. One of them is the amount of wood waste that will be required on an annual basis to feed our biomass system. The user must verify the availability of the fuel with the supplier. In the cost section, clicking on the Show Data arrow allows the user to review all the costs previously entered into the energy model sheet. Additional costs could also be entered using the user-defined cells. In this case, a building and yard construction cost of $150,000 is added to the initial cost section. The cost of fuel for the proposed case is included into the annual cost section, and the cost of fuel for the base case is considered as an annual saving. The initial cost and O&M cost entered in the energy model sheet for the biomass system included equipment, system installation, fuel handling, etc. If the user would prefer to enter all the costs individually, this could be done in level 2 and 3 of the cost sheet. Furthermore, in the level 3, by clicking on specific project cost and selecting fuel handling system, the user enters additional costs related to the fuel handling system. The emission sheet calculates the difference between the proposed case and the base case greenhouse gas emissions. With this project, there is a reduction of greenhouse gas emission of 664 tons of CO2, which is equivalent to more than 150 acres of forest absorbing carbon. In the financial analysis, a premium rebate of 40% has been assumed. This means that the end user is willing to pay more for the heating energy delivered by the biomass district heating system than what it was paid for heating in the base case. The building owner could be motivated, for instance, by the fact that the existing system can be removed and no future maintenance or operating costs will be required. It is observed that the internal rate of return will drop from 21.9% to 9% if the rebate is removed.